Well, hello there. Okay, so I've mentioned this already in some of the examples we saw, the compound statements that do declarations and definitions. So declaration is like int button state. That says I need a variable named button state, and it's going to be an int, and it's going to be a local variable because I'm declaring it inside of the function. Button state equals, that's a definition where it says take this value and store it in button state. So these are the two different tasks for the chip to do. One is to create memory, that's kind of a compiler thing, and one is to put data into memory, which happens during the program. But this is a very handy way to do it all in one line, and so you see this in a lot of examples. The problem comes when your instructor says, write all of your analysis and control code in functions. So you have a function that reads the sensors, you have a function that calculates the control, a function that drives the motors. That's how we're going to do it in this class. And for convenience, a lot of students make all of those global variables so they don't have to pass things between the functions. We just have a global set of things that everybody operates on, and that's fine. But here we've declared a local variable. And so if you want to make that global, you have to do it carefully. A preferred format that Arduino examples hardly ever use is to take this compound statement and make it into two statements. So here's the declaration and here's the definition. So we create a local variable and we use the local variable. That's what this is doing, just in one line versus two. I prefer this, but you don't get those in as many examples. And it's a style thing. It's functionally exactly the same. So here is, this top one is a student who made an error. So this is the bad code. What happens is they say, well, my other functions need button state. So I'm going to make it a global variable. So they declare it outside of the loop, variable named button state, integer button state. And then they just miss this, and they leave this code the same inside of their loop. What happens now is we have two variables named button state, and there's no problem with that because one's global and one's local, and local variables are always the priority. So this takes, it reads the button, it stores it in my local button state, and this global variable never gets touched. So student tests the data, and the sensor, if they print it out here, you can see it's printing and changing, it's working, but another function always sees 0 on button state, and that is really frustrating to see. Printed out in a different place and it never changes. Printed out here, it works, and it's because they've got two variables with the same name because they just forgot about this part. The thing you have to do is make a global variable. This is the good version down at the bottom. Here's where I made my global variable, and then I have to delete that little int part that made the local variable that duplicated it. So now I just have the definition here, the declaration up here. I'm going to go back a slide. That's why this is a preferred style, because if I want to change this from local to global, I can just cut this line, paste it up at the top, and I've made that change in a nice consistent way. So look out for that. If you're changing the global variables from compound statement declared local variables, that one is a very subtle thing, and it can make you really hate Mechatronics if you stay up all night trying to fix this. Another common mistake that students make, and this is more of a C thing, is integer math versus floating point math. We generally do all of our engineering calculations in floating point because we're engineers and we don't have to worry about round off and truncation and things like that. But things like the analog to digital converter start as integers. So at some point we generally have to convert. And C will automatically convert, and it should change integers up to floating point, but it does it sometimes in an order that doesn't make sense. So here are two definitions. They're variable declarations where we initialize a variable named k to this value, and C is going to do this math for us just fine. We're declaring it as a floating point, and so eventually it will store it as a floating point. And here I want it to be 30 divided by 45. It's a feedback gain. This is the output over the input, so it's nice to do ratios sometimes. The difference in the second one is that there is a decimal point on the 30 and a decimal point on the 45. The way these are integers, the 30 and 45, and these are floating point because they have a .0 and a .0. And unfortunately, when C sees a line like this, it does integer math to divide 30 by 45 as integers, which is more efficient than floating point math, so that's what it goes for. This is a ratio 0.667, and because it's doing integer math, it truncates that, and you're going to get a 0. So 30 over 45 as an integer math is 0. 30.0 divided by 45.0 is actually 0.667. So this is something that I've seen students do. They're trying to define a floating point number, and it gets stored as 0.000, but because they used integers over here, it did integer math and then converted it. So always put dots, 0.0, if you are doing floating point math. Superstitiously, I just put them in everywhere. The other thing, this will also happen if you're mixing integers and floating points in math. So x divided by I will sometimes do integer math. And there are rules on all of this and how the order of conversion happens from left to right and things like that. But they're hard to remember and they're easy to make mistakes. So I just always put decimal points in everywhere rather than relying on the rules. And if I'm mixing integers and floating point, I explicitly cast this. If you put the type in parentheses in front of the variable, this says take whatever variable type this is, which is an integer, and make it into a float. So this is called typecasting or just casting. So now I've got a float divided by a float into a float, and so it will for sure give me floats. So my style is to explicitly define what I want it to do rather than letting it be implicit. Other programmers disagree and say that this is extra, but I think this is easier to read, and so I'm going to defend it. If you look on Stack Overflow or something, there are arguments about this. This is casting, where it's just changing the variable type. This is the same. There's a function in Arduino called float where you give it an integer and it returns that integer cast to float. So this is a function that basically does this. Sometimes people are less confused by what's getting changed if it's inside parentheses rather than the changing being inside parentheses. They're doing the same thing, so whichever you like. I think this is specific to Arduino. I can't remember if it's a standard C function or not.